Hi everybody. In this problem, we are trying to find the least value of n for which n factorial times n plus 1 factorial times 2n plus 1 factorial minus 1 ends at least 39s. So if something ends in at least 39s like it does here, we know that this number here, if we add 1 to something that ends in at least 39s, we'll get a number that ends in at least 30 zeros. For example, let's just take that 30 down to 3. So if we have 999 and then we add 1, then we'll get 1000, which has 3 zeros. So we are trying to find the least n for which n factorial times n plus 1 factorial times 2n plus 1 factorial is divisible by 10 to the power of 30. So we just try a value of n to see how close we'd get. So let's just try 30. So if n is 30, then we'll get 30 factorial times 31 factorial times 61 factorial. And using Legendre's theorem, we get 6. This ends in 6 plus 1 plus 6 plus 1 plus 12 plus 2 is equal to 28 zeros. Because a number ends in a 0 if a number ends in 30 zeros if it's divisible by 5 to the 30. Normally it's 10 to the 30, but we know that if it's divisible, we know that there are more factors of 2 than 5, so we don't have to worry about the 2. Okay, this is too small by a little bit, so now let's try n equals to 31. Then we'll get 31 factorial times 32 factorial times 63 factorial. But this still has 28 zeros, because no new factors of 5 came in. So now let's try n is equal to 32. 32 factorial, 33 factorial, 65 factorial. So let's see. One new factor of 5. So then this should end in 29 zeros. Okay, now let's try n is 33. It's 33 factorial times 34 factorial times 67 factorial. No new factors of 5 came in, so it's still 29 zeros. But when we try n equals to 34, we'll get 34 factorial, 35 factorial, 69 factorial. And this has one more zero, factor of 0. So then the answer is 34. Thank you.